Okay, so this video includes the recording of questions 1 through 10. And starting with question number 1, as you can see, it's asking you, it says identify the interval where the function is changing as requested, and the request is that it's increasing. You can clearly see that it's increasing, in this case, here, and let me see, I'm trying to get the pen to work for me here. It's increasing here, and it's increasing here. If you notice, this is from the domain, which is -2 to -1, right? And so, or it's also increasing from the 3 all the way to infinity, because remember that's infinity. Here it's constant, just as a quick review. So I'm not saying that there is no increase here. I'm saying this is a constant. I'm trying to get this to be a different color. Let's see, so this is constant here, and here it's decreasing. So the only two places it's increasing are here and here. Remember, we read these left to right. Okay? So the answer choice would have been C for this one. For question number 2, it says use possible symmetry to determine whether the graph is the graph of an even function, an odd function, or a function that is neither even nor odd. And so I remember telling you that functions that are symmetric about the origin, as in this case, these are odd functions. These include, if we go back to the basic, y equals x cubed, we know that the general format of this, it comes from negative infinity and rises to positive infinity, and it's symmetric, or it's an odd function. It's symmetric about the origin itself. So anyway, so this would be C, odd. Alright, and for this next one we have evaluate the piecewise function at a given value of the independent variable. And so in this case you simply are using values as you substitute. So for number 3, that they're not even asking you the value of the independent variable. Okay, so they're saying at h of 6. So in other words, when they're saying h of 6, they're referring to this right here. Basically 6 minus 2, which is 4. Okay, for this one, they're asking you to actually draw it. And so what you want to do is maybe set up an XY table. That would help. So you get some values. And what I would do is I would say, okay, if I have x and y respectively, and I'm using the function that is given to me, at x is equal to 4, that's the fastest and easiest one because there's only one of them. At x is 4, this is -8, and that's no question. Any number that is greater than 4, which is here, so like 5, 6, 7, is just, if you notice your graph is not that large, so 5, 6, 7 would be suffice. In that case, you're looking at the values of -x plus 7. So you would say -5 plus 7 is 2, -6 plus 7 is 1, and -7 plus 7 is 0. And we can also see that this is not inclusive because this is greater than, so not inclusive. And that means that you should have parentheses if that is the case, in this case. So you should have an open value or open point, basically. So let's see. So when x is positive 4, so that is this point right here. That is this first point right here. Because that is inclusive, because x is equal to 4. But then you notice the change in this part of the function where we have right here where x is greater than 4. X is greater than 4, we're looking from this value here over. So that's not inclusive, and you notice if you're going 3, 2, 1, 0 on the y, right? And so that looks like that's it right there. And then negative 7 is inclusive, negative 4. So negative 7 plus 3 is negative 4, so that works. And then not inclusive again, we're back to this, where you have 4 plus 7, 4 plus 3 is 7, and so that's not inclusive. And you can see your points are going to increase this way just by plugging in a few values between them. So let's say you chose 0. When x is 0, y is 3, and there you are, right there. So that proves our point, and so for this, your answer choice should be A. Alright, for question number 5. Now this one is a toughie in the sense of a setup. Most of you are having a little bit of trouble with the setup. So I'm going to do the question down here. Now you will notice that in this part of the formula, you do have an f of x part, this part right here. Well, that's already given to you. You already have that. What you don't have is the f of x plus h, which we're going to work out right now. And then we're going to do the equation together. So let's plug it in. So in this case, we're going to do f of x plus h, and this is equal to 1 over 9. And then now, instead of x, we're going to have x plus h. See? And that's basically what you're going to do for the moment. Alright, and now we throw it into this formula here. And I think this is why this question is so confusing to some of you, because it takes one step just to get the f of x plus h. You don't really have to work anything out, per se. Okay, so let me erase this for a minute. Hopefully you're taking notes as I go along. And then go back to this. Okay, so we have basically the f of x plus h, which is 1 over 9 parentheses x plus h, minus the f of x, which is this, so 1 over 9x, and all of this is over h at the moment, okay? And so anytime you have a situation like this, you need a common denominator. And so what we're going to do is we're simply going to multiply this side by 9 times x plus h, top and bottom. And we're going to repeat this process on this side, but this time I'm doing 1 over 9x over 9x on top and bottom as a multiplier to get a common denominator. Okay, so now I have 9x minus 9x x plus h all over 9x times 9 parentheses x plus h. Okay, and all of this is over h over 1, remember. And again, this is another part of the setup where a lot of you get confused because you forget that this is still h over 1. Alright, so what's going to happen is the 9x's are going to cancel. Alright, because this negative, if I distribute the negative into here, and I distribute that negative 9 into both 9x, the x and the h, I'm going to end up with 9x minus 9x minus 9h, and all of this is over this denominator here, right? So the 9x's cancel, leaving you just negative 9h. So now I have basically negative 9h. Let me erase this so you don't get confused. Alright, so now our denominator or numerator for this part has changed. And it's negative 9h. And now this denominator, or this part of the fraction, we're going to multiply, and we're going to do keep, change, flip. Right? So now this goes away. This has gone away now. Because we've kept the change and flip. And so now we start to reduce this. This reduces to quite a few pieces. So, first of all, this cancels with this. The h cancels with this h. And in this case, you should be left with this answer choice, which is basically negative 1, 9x, x plus h. And you see that right here. Here's your 9x. Here's your x plus h. And here's your negative 1 that remains on top. Negative 1. And all of this sort of goes away. That goes away, that goes away. Okay? In the red, I merely adjusted this part so you can see that this is where the 9x comes from. Alright. Number 6. On question number 6, you have, it says use the graph of the function f plotted with a solid line to sketch the graph of the given function. And they're giving you the negative of f of x minus 1 minus 2. The original function, if you notice, basically is f of x. So what you have is you have a flip, you have a horizontal shift, you also have a vertical shift. And so I'm looking at something that is going to do this behavior. So it's going to come, first of all, I'm going to think of it as some sort of sad phase, right? It's going down. Then, and that's based on the reflection, it's also going to go, remember this is always the hypocrite, so this is a positive 1 shift and a negative 2 vertical. So that means that it's going to go, basically in this case, down 1 and over 2. Right, because it's always the opposite. And so if I look at this, I'm looking at something that's going from 0, 0, over 1, down 2 for the vertex, and then instead of drawing the diagram going this way, it's actually coming this way. So it's D in this case. Okay? Alright, number 7. On this one, this has to do with multiplicity. Okay, and so for number 7, you're looking at this multiplicity being even. So at positive 3, we would say it touches, because this is one of those situations, it touches the x-axis because this is one of those situations where it's kind of curving either this way or this way, depending if it's positive or negative. In this case it's positive, so it should be curving this way. And then you can see that you have x squared minus 25, which is multiplicity 1. So that's going to go through or across. So it has to be, in this case, I would say it's answer choice C, because if I were to factor x squared minus 25, that's obviously x minus 5, x plus 5. And both of those are multiplicity 1, which means that it will cross. Multiplicity 1 refers to that exponent there. Remember, when it's an even, if it's an even multiplicity, like in this case for the 3, you see how you have x minus 3 squared, then it touches the graph. It goes up and down around the graph. Okay, number 8. Look at the exponents. Remember what I said about this? We're looking for y-axis symmetry, origin symmetry, or neither based on the function. And because that has mixed exponents, meaning you have odd and negative, this has to be in either situation. If it were 8x squared plus or minus x to the 4th, then it's even. If it were 8x to the 3rd minus x to the 5th, then it's odd, because they're both odd, right? This is mixed, so it's neither. Okay, number 9. For this one, you have the leading coefficient test. So what you need to figure out is what are the exponent values. So for number 9, I'm looking at this exponent and I'm saying, okay, well, if I multiply this times this, I have a 4th degree, and this is a square, so that's going to be a 6th degree, so it's even. It's a negative even, so it's got to fall both ways on the end behavior and beginning behavior. It's going to fall both ways. So I would argue that this is answer choice D for this one. Okay, if you remember, I said to you, if it's quadratic, say if it's x squared and it's positive x squared, it goes like this, right? So they both end up. If it's negative x squared, don't they both end down? So look at your function, even if it were a fourth power, say if it were x to the fourth, then you have this type of behavior, right? You know, the terms always are, remember the terms are always one less than the power. If it were negative x to the fourth, then it looks like an m, right? I mean, I hate to be negative, but if it's negative, it's like misery, isn't it? Misery looks like m. That's an easy way to remember it. Sad though, but true. So yes, you have to remember though to multiply. So x cubed times x is x to the fourth, and then this is obviously a square, so this is x squared. So x squared is going to end up giving you x to the sixth because you're multiplying these. Okay, and number 10 for this part is the last part. It says find the zeros of the function. And so we always begin by the factors of the constant divided by the factors of the leading coefficient. So in this case, you would have 1 and 6 plus or minus of each, and plus or minus 2, plus or minus 3. And then now we test the values, the different values. Okay, so let's start with 1. Okay, so if I use synthetic division, I say, okay, does 1 divide into 1, 6, negative 1, negative 6. Okay, so I'll drop the 1. 1 times 1 is 1, that's 7. 1 times 7, that's 7, that gives me a 6. 1 times 6, that's 6, that's a 0. So yes, so I have x minus 1 as a potential 0, leaving me x squared plus 7x plus 6. Okay. And so, since I know x minus 1 is a potential value, which means that x is 1, right? That's what that means. Let's try negative 1. So if negative 1, is that a potential factor for 176? And again, always make sure that these exponents are in exponent order, descending order. So negative 1 times 1 is negative 1. That leaves me a 6. Negative 1 times 6 leaves me negative 6. This is also a 0. And therefore, x plus 1 is another 0 of this equation. And this being x plus 6 as a factor, because remember, you're losing an exponent. If you notice, I went from x cubed to x squared to now x. That means that x equal to negative 6 is my other 0. I don't even need to work that one out. So your answer choice should be 0 for that one.